Welcome back. This, I believe, should be the last video. I just want to speak about two things. Number one, as I've written up there, is a bit of caution in regard to wiring your PLC. And then number two is just something small on the what I call anomalous behavior of normally closed contacts vis-a-vis the software. Maybe I should add there vis-a-vis the step 7 software. So in regards to wiring, it's just a simple idea but in the lab, in the first week of labs, I saw that many groups were making a mistake, so I can preempt it now. It's the fact that, remember, the PLC is usually connected to sensors. So if this is my PLC, it has inputs, I/O ports there are many of them. In our case, we have 13, and then we have, sorry, up there you've got input, and then at the bottom you have output, the Qs. In our case, we've got 16 outputs. Now, remember, these at the end of the day will be connected to, the inputs will be connected to sensor devices. So if I have sensors, so let's say this is sensor 1, and many of them. But of course, I could connect that here. In our case, in the lab, a sensor will be simulated by a switch. So actually, let's say they're connected to switches. So there's switch 1, switch 2, and as many as I need. So each switch will be going straight to one terminal of your PLC, and switch 2 goes to another terminal. Similarly, my outputs will be going to an actuator in the real world, but in the lab, we're going to simulate an actuator by just an LED or a lamp. So let's call them L, so I can have lamp 1 and lamp 2 and as many as I need, and then my output goes to the lamp, my output goes to L2, and so on and so forth. The only thing I wanted to caution is that, look, differentiate between a ladder diagram and the actual wiring of the PLC. So for example, if my ladder diagram was something of this nature, supposing I have, this is S1, and this, then I have S2, and maybe it goes to a coil, which coil I'm labeling lamp 1. Okay, so my PLC is just something like that. This does not mean, how can I say, the ladder diagram is just a configuration or a representation of the actual program or circuitry you're creating inside the PLC. The ladder diagram does not correspond to the wiring outside of the PLC. So in as much as you may see over here, this, it may lead you to think that S1 should be connected to S2 somehow, but that should not be. In the outside world, S1, the actual physical switch S1, or the input from the sensor, it goes straight to the address of S1, which maybe could be I0 dot something, I0.1 maybe, and S2, the physical S2 input, the wire from the switch goes straight to I0 dot whatever it is, maybe 2 or 3. So outside, in the lab, we found a situation where when you look at the ladder diagram, it may lead you to think that S1 should somehow be connected to S2 straight. So that should not be the case. So outside in the physical wiring, do not connect a sensor to another sensor, and do not connect one actuator directly to another actuator. So you can take it as a rule of thumb, there should be a one-to-one relationship. So a one-to-one relationship. So meaning that, by this I mean that one sensor, one switch if you want, to one input of the PLC. Let's say one PLC input only. So never have a sensor connected to two things, meaning one sensor is connected to another sensor and then both of them to the PLC. So I'm saying this, and easily in the lab it will be violated, but it should not be. And similarly, I can say that one PLC output should be connected to just one and only one actuator. Alright, so even in a situation where I could give you another illustration here. In a situation where, supposing my ladder diagram ends up being something like this, for some reason, maybe it ends up being like this. So this is lamp 1, and then this is lamp 2. You see, when you look at the ladder diagram, you may be tempted to think that, yes, I should wire lamp 1 straight to lamp 2, and then wire them both to some other terminal of the PLC or something of the sort, but that should not be the case. Meaning lamp 1, like I said, the PLC is there, you tap an output and it goes to lamp 1, and that's it. So lamp 1 should never be connected to anything else other than the PLC. Similarly, lamp 2, which is the actual lamp, should only be connected to the PLC and nothing else. So don't have a connection here like this because you're seeing this connection here. It's in the lab we found that happening many times, but that's not the case. So just keep in mind that rule of thumb, and so this should be kept in mind in the lab. I've given throughout these videos a number of rules of thumb, so just try to remember them. Mainly, well, two come to my mind right now immediately. There's this one that I've just spoken about, and the other one that I spoke about is that no two coils should have the same address. Fine, and that's what I wanted to mention in regards to the caution in regards to wiring. I hope it's clear. If it's not in the lab, you should ask questions. The second thing I would like to mention is the anomalous behavior of normally closed contact. Now, when you're implementing a ladder diagram in the lab, there's a funny way in which normally closed contacts operate, and I like to explain it in this way. You can visualize a physical world or physical wiring, physical outside wiring, and you can visualize another world inside the PLC where you create the actual ladder diagram. So then these will give you a kind of net effect. So, and this is in the context, we are speaking about this for normally closed context, normally closed behavior. And it's important, otherwise the things will not work. Now, in the physical wiring, if I connect a normally open contact, meaning physically I wire a terminal of the PLC to a normally open switch or a normally open device of whatever nature, and then inside the PLC, the contact that switch is controlling is also a normally open, then the net effect will be normally open. If outside the PLC, in my physical wiring, I have a normally open contact, but inside the PLC, in my ladder diagram, I use a normally closed. I'm representing normally closed by 1. If I use a normally closed contact, then the net effect will be normally closed. If outside the PLC, I use a normally closed contact, and inside, in the ladder diagram, I have a normally open, the net effect is normally closed. And lastly, if outside the PLC my wiring is to a normally closed device or switch, and inside I also use a normally closed switch or rather contact to represent that input, then the net effect of that will be normally open. You'd expect it to be normally closed, but it will be normally open. So it's like the normally closed inside reverses the action of the normally closed outside. Now, if we want to achieve an actual normally closed net effect, I hope from this you can see that this is the region where I have to be operating. I have to be operating in this region if I want to achieve a net effect of normally closed. What that tells me is that when I'm implementing my design, I have to keep in mind that I must use one of these two configurations. Either my physical outside wiring is I use a normally open, and then inside the PLC ladder diagram I use a normally closed contact, and the net effect of that will be the net effect of that will be normally closed. Or the second option is to use a normally closed physical wiring, and then inside the PLC, that contact is represented by a normally open contact, and in that case, the net effect will also be normally closed. So you should use one of those two. There are reasons which would advise you to take one or the other, and different people in different places might have different conventions. But then if you choose this first option, remember that inside your PLC, you're going to be using a normally closed, and that's fine. So even when someone looks at the ladder diagram, it's clear to see that, okay, here you're actually using a normally closed. But they would have to keep in mind when it's being wired physically, a normally open would have to be used. If you use the second convention, in your ladder diagram, you will be actually using a normally open when you know that that represents a normally closed. But in the physical world, it would be wired as a normally closed, in which case you would have to put a proper documentation in the PLC program, maybe the comment, and say that this contact, in as much as it looks like a normally open, it is a normally open, but the net effect is meant to be a normally closed. So the documentation in that sense should be clear so that the implementers of your design know exactly what to do. Yeah, so that's just something worth keeping in mind. It's a bit of an anomalous behavior, but that's how it is. And in the lab, you shall see that in your design. So as you're designing, you should just keep that in mind. Wherever you have a normally closed in your design, keep this anomalous, what I call anomalous, that's just my terminology. Keep in mind this anomalous behavior so that when you're implementing, you know exactly what to implement. Fine, and this was the last video as I promised. I've already spent so much time in this, but I hope it's useful. But more than anything, I hope it'll save me time, because I don't want to have to go through all these ideas for every single small group that is coming to the lab. I'll scroll up here. I had written a summary of all that I've been speaking about. So please, whether you watch these videos or not, just at least these ideas that I put down here, try to understand them. So earlier on, I spoke about relays, digital logic, and programming environment. We spoke about the basic elements. We spoke about the flow of logic, going from left to right, top to bottom. We spoke about every element being addressable, the different memory locations. I spoke about the scan cycle. I gave you a rule of thumb, 2 coils. So this was one rule of thumb, which is very crucial. So we spoke about use of timers, bit logic. Yeah, I've also given you another rule of thumb, kind of. All right, don't connect a sensor to another sensor or an actuator to another actuator. We've spoken about, I've introduced you to the software and the simulator and how you can create your own programs outside the lab and test them. I spoke about the instruction set, which is very important, especially if you're to advance in your knowledge, because what I'm giving you in the lab is very little, but then you can read more on the instruction set. And finally, I've spoken about the anomalous behavior of normally closed contacts. So this is just a bit on the Siemens S7-200, and I hope when you do the lab, you'll be able to explore these concepts much more, and even more so on your own.